Hi, Andrey.
Hi, Alexei, glad to see you.
Yeah, likewise. Can you tell us a few words about yourself and about the tool you want to show us?
Yeah, sure. So I'm Andrey. I come from technical background and used to work at JetBrains for many years. This is where I got introduced to developer tools and developer productivity as a topic. And last 3 years at JetBrains, I've been involved with improving the support for Jupyter notebooks in PyCharm. And this is how I got also introduced to data science. And yeah, I get very much interested in, this is how I got into that topic. And since the beginning of this year, working on the open source project, dstack. So basically quitted JetBrains to fully focus on dstack. And I'm quite excited to tell more about the tool.
Yeah, please. I'm also excited to see this.
Sure. Yeah, let me maybe bring some context around the tool and before I can give a demo. Right, so unlike traditional workflows where we build software, we typically, for example, work with an IDE and then we write code and we can run it locally. In machine learning, as you know, it's slightly different, mostly because of the need to use high-end hardware and GPU, and you have to often have to deal with a lot of data. And that's why it's not often the case that you can use your local machine. Sometimes it is the case for a small project, you can actually use your laptop or your own GPU card. And this is a big problem. And this is why Google Colab, for example, is so much popular that people use it to train models. But when, for example, if you ever used a remote machine for machine learning, you know the drill, right? You create an instance, then you use SSH to log in there, then you have to deal with setting up the infrastructure. Sometimes there's a pain with the SCUDA drive and all. And then you use a screen or some other tools to keep the session alive while your script is working, sometimes for 6 hours. And then, well, if it's cloud instance, once the job is finished, you have to turn it off to not to overspend. So that's a lot of manual work. And sometimes people do that simply because they do it once in a while and then it's fine. Sometimes they can even open that remote machine in the IDE, which helps a lot. But when you start to do that on a regular basis, you immediately start to feel pain because you have to go through it again and again and again. And that's why you start to think, okay, so how do I automate that? And that's also one of the reasons why, tech-forward companies built the internal platforms that automate that. Sometimes it's a little script that just schedules your job and then saves the data. And sometimes it's more complicated, especially it depends on how complex your MLOps, let's say, setup is. And so there's one benefit in that. If you can afford to automate it yourself, then you can tailor it towards your needs and then make it friendly for your specific project, and you can use any tools that you want. If you cannot do that, for example, then often it might be the case that you can find yourself using one of these MLOps tools that are in the market right now, like SageMaker is one of them, there's Kubeflow, and there's a lot more. And they do automate this thing, and they do, let's say, address the pain point to a great extent. However, often if you talk to people that use these platforms, you may often hear that, these tools typically cover it end to end, and that's the source of this leaky abstraction sometimes, and it gets quite opinionated, and you have to follow it all the way, and it is not as flexible as you would want it to. And most importantly, in MLOps topic, we talk a lot about reproducibility, about versioning things, and MLOps platforms often preach that. They do push you into using notebooks more than I would say it is needed. And you may find sometimes yourself basically switching out of your productive developer environment, cozy, which you set up with, I don't know, and find yourself working with some remote notebook and going through some open-ended cycle. That's the thing. And in the beginning of this year, basically, I thought, yeah, so can we bring some more developer productivity to that process and maybe try to build a tool that would not be as opinionated as MLOps platforms, that would not be that complex and would rather allow you to run your machine learning workflows and while you staying in your favorite IDE or terminal, and then not pushing you towards using Python scripts when you don't want, right? And so that was the idea for the tool. And yeah, so dstack is such a tool, and happy to show how the tool works in detail.
Yeah, I've been talking about this so much, so I really want to see it. I'm so excited.
All right. Yeah, so first of all, dstack is an open source one, and yeah, you can find the instructions how to install it and how to use it on GitHub. There's also a documentation website. And that's one of the things which are, let's say, special about dstack. So in order to get started with dstack, you don't need to set up any things on your, let's say, cloud side or on your Kubernetes cluster. All you need is just install the Python package called dstack. So basically, if you want to install it, you basically write pip install dstack, and that's mostly it. Then right. So that's PyCharm, but you can also use any other code editor, VS Code, whatever. And this is the terminal. So in order to get started with dstack, you have to simply install the pip package. And then you have to do two things. Like first one, you have to make sure that you have your AWS credentials configured locally. It is pretty easy to do. You just go to your AWS account and then create credentials, make sure that it grants you permissions to all what is important. Basically, we are going to use, we are going to run ML workflows in AWS. That's why the credentials need to grant permissions to provision EC2 instances and then store data in S3 bucket. And then you have to run the dstack config command. What this command does is it asks you, okay, so if you want to run your ML workflows, what region you want to run it in, and the default is fine. And then it asks you, all right, so you're going to run ML workflows. Where do you want me to store the state? Which workflows are running, which are not, where to store artifacts, the output artifacts of the workflows if you'd like to reuse them. So you can provide a name of the S3 bucket within your cloud. Well, if you don't want to pick a name yourself, it will help you generate the bucket itself automatically. And that's basically it. So now you can run ML workflows with dstack. But before running ML workflows with dstack, let's see what we have here in the project. So this is just a demo project, and it can be anything. In your case, what we have here is we have some code. For example, here we have some scripts. Typically, it's a training script. We also might have some scripts that process data and all. And what we often do, for example, if we work with it locally, we just run, for example, Python train.py, and this runs the script locally, and you sometimes might want to run it locally just to see that it works well and all. But at certain time, you may want to run it in the cloud, for example, and this is where dstack comes very handy. So what, in a nutshell, what dstack does is it lets you create a small configuration file where you can describe what is required to run your workflow, any script in your project in the cloud. For example, so dstack, in dstack, you have to create that workflow schema file. That's a very short one, where you have these declarative definitions of their workflow. So for example, in this particular project, we have two workflows. One downloads data, and it uses the download.py script. And another one is training workflow. And what it does, it runs the train.py script. It uses, it has a dependency to some data produced by other workflow, but in a nutshell, it just uses the data from a local folder to train a model, and it saves event file, like experiment metrics files within a local folder. You can, for example, run. Let me see. Right. Yes. So you can, you can also first, for example, have to download. This is how you typically run it locally if you want. And once you've downloaded the required data, you can run it locally, and it will do that. So now imagine that you'd like to use some compute resources that you don't have locally. For example, you might want to use GPU, which you don't have locally, or a very specific kind of GPU. So here in the workload definition, you can, for example, write something like that. And where you can say, okay, I need at least one GPU to run that workflow. Or you may want to, for example, tell that which exactly GPU you want to use. Or even you can tell, for example, one GPU is not enough, I need more. And that's what I want to use to run my workflow. And well, last but not least, you can also tell something like that: interruptible true. So that's the way you can tell dstack to use not on-demand instances, but spot instances. Great thing about these instances is that they are several times cheaper. And the only issue with them is that they can be interrupted at any time. There's no guarantee that they will run. And this is also something that dstack helps you with, because when you run a workflow, dstack allows you to save the checkpoint. And then if you restart the workflow, it may start from where it got interrupted. So it basically is taken care of. So now, for that particular animal, let's say we're not going to use GPU, but basically in order to run the workload with dstack, the only thing you have to do is dstack run train, and that basically it. So what the tool does is on the fly it provisions the required compute resources which you've described in your declarative definition, and once it's provisioned, it fetches the exact version of your code which you have locally. So for example, you can edit your code and you don't have to worry about committing these changes to your Git repository. As long as it's inside your Git, you can make local changes without having them committed, and dstack will handle that automatically. So when it runs the workflow, it fetches this code. If you have dependencies, it will, for example, while we're waiting for the workload to start, it typically takes roughly less than a minute. What we can do, so for example, when we run some workflow, we can also add a tag, for example, missed data. So we can run a workflow and save its artifacts with this tag. And then we can reuse this output artifacts from another workflow using this tag. And so, for example, what else this command allows you to do? So if you just type dstack, you can see a little cheat sheet. You can run workflows. You can also see the status of current runs. So for example, dstack PS that shows you, okay, so this workflow is running. And by the way, while it's running, you can see the output. So it just started. And you can also see, let's say, tags. If you've created a tag, you'll see it here, and then you can delete the information about your workflow, but the artifacts are going to stay stored, and you'll be able to reuse them. Right. Then there's a number of additional commands just to help you conveniently run workflows. For example, you can configure secrets. For example, if you'd like to use some tokens, for example, if you use weight and biases to store metrics, you can add a secret with your weight and biases API token, and then while you're running the workflow, well, dstack is using the encrypted storage of that secret to make sure that you don't hard code it and you don't share that particular secret. Right. So yeah. By the way, yeah. Now we see logs coming, but the workflow is already done. So now, if we, for example, yeah, let us see how we can also work with the artifacts, for example. So now we see that the workflow is done, and we can, for example, use the command artifacts, and we can pass the name of the run. And we can, for example, see the actual artifacts. Whenever we want to download these artifacts locally, we can use the command download, and then it will, by default, it will just download in, sorry, the current directory. So yeah, as you see, this is a super lightweight, super simple tool. It's basically just a CLI, a command line utility. You can use it with your existing project. You don't need to change anything in your project. You just need to add this simple YAML file and make sure that your AWS credentials are configured. And then it's up to you. You want to run it locally, you run it locally. You now want to run it with some additional GPU resource and all. You do that. Maybe last thing to add to that, all the state is stored in the S3 bucket, and all the workloads, whatever repository you running workloads with, it's all the state is stored and can be reused. For example, you can reuse the output artifacts from other projects. For example, if you have several projects and one project prepares data, for example, dstack AI prepare data. So you run the workflow and created the tag in this particular project, and now you can reuse it from other projects. So basically, you can have multiple projects, you can run workflows there, and you can reuse them. If some other user is also using dstack and is using the same S3 bucket, then there'll be full transparency. So you'll be able to use tags and artifacts from other users in your particular project. Yeah, so basically that's the overview. But it's super easy to get started with and learn how the tool works.
I'm just curious. So with this example, when you run the train job, you have a dependency to this missed data, right? In this case, if the dependency is missing, if artifacts are not created yet, what dstack will do? Will it try to run that job, or it will just complain, hey, I don't see this, the data with this stack, the dependency with this stack is not generated yet. Please run that first and then come back.
Yeah, so right now, if you, for example, try to run something that is using an artifact or tag that doesn't exist, it will explicitly tell you that. So we have an experimental feature which we not enabled that allows you to schedule something. So for example, instead of the tag, you can also use workflow, and then you can use the name of the workflow here, for example, download, and you can run that. And what will happen in that case is that it will use the artifacts of the latest run of that workflow, but it will not trigger that download workflow explicitly. But as I said, we thinking of probably adding a feature that would allow to pipe workloads together, but that's something to basically work on.
I'm also curious what kind of environment you have here. So I see that provider is Bash, so apparently it's some sort of Linux or at least Bash. But is it like Ubuntu? Is it Amazon Linux? What kind of Python is there? Like, is there a way to control this at all?
Right. Thanks. That's by the way a very good question, and I just forgot to tell. So, for example, if we go to, let's say, the documentation, for example. So let me see, reference. So here we have providers, the list of providers. And what it means is that within this open source project, there is a number of providers that are built in, and there are more providers can be added. So Bash is the default one, the main provider. And what it does, it allows you to run arbitrary shell commands, and it takes care of the base, let's say, environment. So it makes sure that you have Python of the version which you are using locally. And it is also make sure that Conda is pre-installed. So for example, here's let's say, here's an example of a Python. So you can run Python. So Python binary comes from Conda. And you can also use Conda executable to install packages. You can also use it, install packages through pip. What is also interesting, by the way, that so one of the users is actually using that now. You can even prepare your environment as within one workflow and then reuse it as an artifact from another workflow. So let's say, for example, there is a very complex workflow. You have to install a lot of Conda packages and all, and you can do all of that within one workflow, save it as an artifact, assign a tag to it, and then activate it through Conda from another workflow.
That's interesting. And but you didn't say which Linux is it, which distribution? Is it Ubuntu or something else, or we shouldn't depend on that?
Yeah, that's a good one. So it's all in the sources. So you can find the Docker file in the sources, and well, if there's a need, you can even change that. But it's Ubuntu, and it pre-installs certain developer tools which you typically need, like Git and others. But by the way, now that you've mentioned, asked about providers, so that's maybe briefly talk about other providers which are built in. So there is Docker provider. Just in case, if you want to use something very specific, you can use Docker provider and provide your own image. That will work. And also there is this code lab and notebook providers. So what they do, they, instead of running a workflow, they running a dev environment. So for example, let us see how it works. Let's see, for example, you need a dev environment with certain resources, right? What you can do is, for example, ID, provider, code, and then you can say, for example, let's basically try it if it works. I'm not sure if GPU is available right now in the pool, but let's see if maybe it works. Resources. So now dstack run ID.
So it will run something, but it will not terminate it, right? And you will be able to sort of SSH or connect to this from your VS Code, right?
Yes, exactly. So it will run an application. You'll be able to open the link and it will have the exact resources which you've asked for. And yeah, and basically let us just see. So basically to take about a minute to start it, but that's nice to see. Meanwhile, what we can do is we can get back to the bash provider and mention another thing which might be quite useful. It's called ports. So let me see. Yes, ports. So a workflow can not only run something, but it also can host application. In order to do that, you just need to tell how many ports you need to open, and then you can access these ports with environment variable. And for example, here's an example of how to host a fast API application. And once it's running, you'll see a link, you can click the link and it's working. And it has all the compute resources which you need. It can use the data, and it also, yeah, basically uses your code to run. So you can use any scripts within the commands which you have like locally in your repository. Yes, still running.
So I still have other questions. So while it's
Sure.
running, maybe I can ask these questions. How many people are working on this stack?
Yeah. So right now we are three folks, three engineers working on it, but we also work in close collaboration with some users who is helpful providing feedback. And we also, yeah, welcome to contribution.
So 3 people are working full time on this. Do you
Yep.
have an external contributor or not yet?
So we have one external contributor, and our team is three people that who are working full time on it.
If somebody wants to contribute, how do they go about this?
Yeah, so that's very straightforward. So here's the GitHub repo, and
You
here's
have a
the
pull request.
yeah. There's a pull request, and yeah. So basically, it's quite it's taken a while to merge it because it's we are trying to understand. Okay, so what is the best way to organize examples? So that's pull request related to that. But hopefully we'll merge that soon. And also there's these issues. Yeah.
You have a good first issue, right? So if somebody wants to start contributing, they should go and filter issues by this tag, right? And then
Yeah,
that's a good way
totally.
to get started, right?
Yeah, absolutely. We have a couple of them right now. We have some already closed, but totally more issues will appear here in this repo.
I
Yeah.
saw one issue was about Azure. Was I not mistaken? Yeah, support Azure Cloud. So and GCP Cloud. So right now you only support AWS, but I guess one of the things, it was even issue number 1, support GCP Cloud. So it's on your roadmap, sort of, right?
Totally. Yeah, so that's exactly something that we want to work on because well, different teams use different providers. And in addition to GCP and Azure, we're also looking into supporting other platforms which provide cheap GPU. So this is something interesting for us. We are now considering some options. For example, there's TensorDoc and a few others that provide really cheap GPU, and I think that could be cool to use them with that platform.
Okay. So apart from that, apart from adding more cloud platforms, what are your plans? What, like in the, let's say, short middle term plans? What do you want to work on?
Right. By the way, here's the workflow.
Cool. So you just open
Um,
this and then you have your VS Code, or
yeah. So this is the VS
so
Code.
it's in the browser. That's cool.
Yeah.
Can you connect to it with your desktop app?
I think that is possible, something that we haven't tried ourselves, but
You probably need SSH to that, right? And then you need to figure out how exactly to store key pairs and all that stuff, right?
that sounds like a good issue to submit, and then maybe even to contribute, because all parts that needed to make it work are there. SSH is just a port to open there, and it totally can be integrated. So here we go. NVIDIA SME, and we can see that we have one GPU which we requested.
It's a spot instance, right?
This one is not, but you can
This one is
create
not.
spot
Okay.
instance, yeah, for sure.
And it probably has Git, right? So then you can.
Yeah.
I'm just wondering, in this case, how do you save the results of your work?
Right. So this is something. So one thing is, for example, when you define that workflow, you can actually also define artifacts. So you can mark certain folders as artifacts, and by default, dstack stores them when the workflow is either stopped or done. And also one thing that you might consider is, for example, let's say path outputs. And then another thing is there is a special thing called mount. So for example, if you add mount to a particular path, it's going to be handled in real time. So basically it means that every file operation on that folder will immediately save or read file in a storage.
Some sort of you run some sort of AWS S3 sync there, right? Or something like this.
It's Fuse. It's called S3 FS. Yeah.
Okay.
It must.
Okay.
It must be used with well, basically carefully, because well, every operation will be an HTTP request. So it works really well for large files, especially when you store checkpoints. You just need to be sure this folder is real time, this is not real time. So you just need to make a conscious decision which particular folder you wanna mount. That's one part of the story. And second is, we are thinking, okay, so another way would be, if you'd like, for example, to save the code, you would probably have to use Git for that, which is available there.
And then you need to make sure you have SSH keys there, right? Somehow.
Yes, that's another one. So there is
or
a special,
I don't know, have some sort of other authentication.
Exactly. So there is a dstack init command, and what it does, it allows you to, well, so that's a good one. By default, it just makes sure that dstack has access to the repository. But for example, if you add help, you'll see that it allows you to configure a token, which is also stored in the encrypted storage within your cloud, or a private key that you want to also upload and store it as a secret. Then dstack would configure all of that, and you'll be able to commit your code yourself.
Okay, that's pretty neat. And now when you stop, it will synchronize, it will save all the like if mount wasn't true, if mount was false.
Yeah, exactly.
Right? You stop and then it just saves, like flashes everything to the artifact store, right?
Yeah, by default, it does exactly that. But if you, for example, add a specific argument, then it will abort it without storing the artifact. So it's basically up to you to decide how you want to handle it.
Okay. So what about my question? The question
roadmap.
Roadmap, exactly.
Right. So there's a number of things, right? So dstack is a young project, let's say, and we have short-term and long-term. So within short-term, of course, we want to make sure that developer experience is nice and it's working in all the cases. And there are some already issues there. One thing is one of the things we want to support local options. So for example, you could run some workflow, but indicate that you want to run it locally.
Just for testing, right?
Just for testing, exactly. So for example, sometimes you want to you want to use your local machine, but you want to store the state, the artifacts in an S3 bucket, for example, centrally. And sometimes, okay, so now it's ready to run in the cloud. Now I can add some compute and run it within the cloud. So that option is in plan. We just right now, basically, hopefully this week we'll make a release where we improve their output, the interactive output. So often when you train a model, you use some kind of progress indicators for training TQDM. Right now, there is little glitches if you use that. If you, for example, see the live output, and we're gonna solve that pretty shortly. And yeah, so and then we're also considering a more flexible configuration. So for example, right now it's only AWS and it's only S3 bucket, but we are looking for a more flexible configuration.
Maybe Minio support or something like that?
Yeah, these two, so luckily Minio is compatible, so but totally, exactly, basically different ways of how companies prefer doing that.
Is there a way to set S3 endpoint right now and just use Minio, or not yet?
No, right now, you need to give a name of the bucket and it will use the S3 API. But that sounds exactly like something that we wanna consider doing.
Yeah, good first issue, maybe, right? I mean,
yes,
it shouldn't be too difficult
totally.
to implement, just somehow specifying the endpoint. Cool. Okay, last question from me. Do you have any advice for anyone who is watching this?
I would just say that the contribution is really welcome. So if you like dstack, it would be great if you could check out the repo and try to understand how it works and try to fix something that, for example, you want to improve. That would be super cool. And our team is there to help with that. So we can help you get on board. There's also a link in the documentation page where you can basically contact us so we can help.
Okay, yeah, thanks. Awesome demo. Thanks a lot for showing it to us. Really great work. Thanks for doing this in open source. Yeah, so
thank you,
Andrey.
Alexei, for having us. Super excited about this chance. Thanks.
Okay, bye everyone.
All right, bye.